Hi, thanks for joining me for this video. We're going to discuss data graphics, how you can represent your data in a graphic form. So the first thing is a frequency table. Generally, it has two columns. One column lists the possible values of the variable, and then the other lists how many items fit into each category. You also sometimes have a third column, and that's the relative frequency. That tells you the frequency of each possible category in relation to the whole. So this is given as a decimal or percent or fraction. A class interval is used when you're grouping quantitative data into categories. So sometimes you'll have a lot of different scores. Like let's say you want to get all the scores that the students registered for college algebra made on their common final exam. And let's say the college has 1,200 college algebra students. You're going to have a wide variety of scores ranging probably from 0 to 100, assuming there's no bonus points available. And you could, theoretically have 100 different scores, 0, 1, 2, 3, 4, etc. And that's assuming that there aren't any half points. So it wouldn't be very helpful to have all the scores listed or to have a tally of every single score. So instead what they do is they give classes. So you might have the intervals set at intervals of 10. So maybe 0 to 9 or 1 to 10 is the first category, let's say 1 to 10, and then 11 to 20 would be the next, and then 21 to 30 would be the next, and so forth. Let's look at some examples. So using the given information, construct a frequency table. Include relative frequency in your table. So we're going to have 3 columns. We're going to have the category. So in this case, it's pet. We're going to have the frequency. And we're going to have the relative frequency. Okay. So we have this chart. It has different kinds of pets in the chart. I see that we have dog, cat, fish, hamster. And that looks like all the different types of pets that are in this chart. So each category or each type of pet gets a row. And now we want to fill in the frequency. So for dog, we're going to count how many times we see dog. So 1, 2, 3, 4, 5, 6, 7. So there are 7 people that responded that they have a dog. Okay, next we're going to count cats. So 1, 2, 3, 4. So I counted 4 cats. And then we're going to count fish. So 1, 2, so 2 fish. And then there's only 1 hamster left. So there's a hamster. So 1. If you want, you can add up. So totals. 7 plus 4 is 11. Plus 2 is 13, plus 1 is 14. So the total here is 14. You're going to need that total in order to find the relative frequency. So for each one, what you want to do is you want to take the frequency, so for dog it's 7, and divide that by the total. So 7 over 14 is the relative frequency. If you were going to leave it as a fraction, you could just reduce the fraction, or you could write it as a decimal, or you can write it as a percent. So I'm going to write this as a percent. So this is 50%. Okay, next I'm going to find the relative frequency for cats. So there were 4 cats out of 14 total. So I'm just going to divide that to get my percentage. So when I divided 4 by 14, so 4 divided by 14, I got 28.6% rounded to the nearest tenth. Okay, so now I'm going to do fish. So there were 2 fish. So 2 out of 14 were fish. So when I do that, I get about 14.3%. And again, if you left them as fractions, you would just reduce. So that would be 2/7 for cats, 1/7 for fish. And then the hamster is 1 out of 14, so that would be in lowest terms as far as the fraction goes. And then you would just divide to get 7.1%. So if you added the percentages, so 50 plus 28.6 plus 14.3 plus 7.1, you should get 100%. Now keep in mind I rounded those decimals, so sometimes if you round your decimals, you might add up to 99.9% or 100.1% or something very close to 100%. But if you had not rounded and you added them all up exactly, you would get exactly 100%. If you add up all of your fractions, you'll get 1. So the relative frequency should always add up to 1 or 100%. So there is our frequency table for number 1. Now let's look at the second one. So in number 1, we had categorical data, so it's qualitative data. In number 2, we have quantitative because it's numerical. So the data below shows the student scores on a recent math test. We want to construct a relative frequency table for the scores earned. Use class intervals of size 10 beginning at 1. Okay, so let's see. First, we have to have our classes. So it says the intervals need to be of size 10 beginning at 1. So 1 through 10 is our first class. Our next class will start at 11 and go to 20. Our next class will start at 21 and go to 30. And so you can see on the right-hand side, you're just adding 10 each time. And that's the same with the left-hand side. That indicates that you have a class interval of size 10. We started at 1 like it said. We're just going to continue to go all the way up to 100. So it's important to note here when you're making classes, all of your intervals should be the same width. So they should all be of size 10. So there should be 10 items in each class, or 5, or whatever your interval size is or your class width. It should be the same for all of your intervals. So that's important. The next thing is notice that there's no overlapping numbers. So every single number that we have in our data set will belong to only one of the classes. So there's no overlapping numbers. And also notice that our classes include every possibility. So if we wouldn't have gone all the way to 100 and we would have stopped at 90, we would have problems because some of the values in the data set would fall outside of our classes, our possibilities. So after you determine your classes, the next thing you want to do is get your frequency. So you're going to look at your data and see how many of each value appears within the class. And then you're going to do the relative frequency. Okay, it's helpful at the bottom to get a total. Remember that you will need the total to do the relative frequency. Okay. So let's look. Let me go ahead and make lines here to make it a little bit easier to see. Okay, I didn't give myself much room at the bottom. Let me just adjust this a little bit. Okay, so let's start counting up what we have. So from 1 to 10, so right now I'm looking for numbers between 1 and 10. So 5, 2, those are the only numbers I see between 1 and 10. So the frequency will be 2. There are 2 scores that are between 1 and 10. And that's inclusive, right? A 1 would go in that class and a 10 would go in that class. So the next class is anything between 11 and 20. So that's what I'm going to look for next. So there's 1. Looks like only 1 is between 11 and 20, and that was a score of 13. So I'm just kind of marking them off as I go. If I miss one, then I can just add it in when I get there. So now I'm looking for scores between 21 and 30. 1, 2. So I saw 2. So there are 2 scores between 21 and 30. Now I'm going to be looking for scores between 31 and 40. 1, 2, looks like 2. All right, next I'm going to look for scores between 41 and 50. 1, looks like 1. All right, next I'm looking for scores between 51 and 60. There's 1, 2. So I saw 2. Okay, now I'm looking for 61 to 70. 1. I only see 1 in that range as well. Now I'm looking for scores between 71 and 80. 1, 2, 3, 4, 5. Okay, so 5 of those. Next, let's look for scores between 81 and 90. 1, 2, 3. So I counted 3 of those. I noticed while I was counting I missed one, so I'm going to go back and get that. But for now I'm going to keep going. Now I'm looking for scores between 91 and 100. So 1, 2, 3, 4, 5, 6, 7, 8. Up, not 90. So that's 7. Okay, now I missed 2 of them. I'm going to highlight them. I missed 73, so I need to go in and add that in the correct interval. So now instead of 5, I'm going to have 6. And then I also missed 90. So I need to put 1 in that interval. So instead of 3, I'm going to have 4. So originally when I was counting this, I was counting 90 in the last category, but that would be incorrect. So just, be careful and take your time. Make sure you have all of your numbers included. So have a systematic way to go through, like mark them off as you use them. You can also create tallies if you want. And then once you're done tallying, just put the number in the frequency table. That's another possible way to do it. What you want to do now is add up all your frequencies to make sure you included everybody and it adds up correctly. So 1, 2, 3, 4, 5, 6, 7. So we should have 28. If we add up our frequencies, let's see if we get 28. All right, when I added them all up, I did get 28. So that is a good sign. So now in order to find the relative frequencies, I'm simply going to make a fraction of the frequency over the total. So 2 over 28, 1 over 28, 2 over 28, 2 over 28, 1 over 28, 2 over 28, 1 over 28, 6 over 28, 4 over 28, and 7 over 28. So at this point, I want to divide to give percentages. So for 2 over 28, I got 7.1%. I'm going to put this in red again as well. So 7.1%. So everywhere I see a 2 over 28, I'm going to be able to put 7.1%. Okay, I have a bunch of 1 over 28s, so let's see what I get for that. That's going to be 3.6%. Okay, now I have 6 over 28, so that is going to give us 21.4%. 4 over 28, that will give us 14.3%. And then 7 over 28 will give us 25%. So you can either add up all your fractions and make sure they add to 1, or you can add up your percentages and make sure it's 100% or very close to 100%. Remember that since I rounded some of these, it may not be exactly 100%. Let's see what I get. Okay, I got 99.9%. And again, that's off because of the rounding. But if you added up all your fractions, you would get exactly 1. Okay, so let's look at the next part. A bar graph displays a bar for each category with the length of each bar indicating the frequency of that category. Bar graphs are used for categorical data. So we want to create a bar graph for the information given in number 1 above. So we're going to create a bar graph for this information. So in a bar graph, you're going to have a vertical and a horizontal axis. On the horizontal axis, you're going to label your variable of interest. So in this case, it will be our categories of pets. So we'll have dog, cat, fish, and hamster. So you want to make sure you label that your horizontal axis is your pets. Your vertical axis is going to be the frequency. So our frequencies range from 1 to 7. So your intervals should be of equal length. I'm obviously hand drawing this, so they may be off a little bit, but you should do your best to get equal length intervals. And if you're using graph paper, that's helpful. Or if you are doing it with a computer, your Excel or Word, you can make one using some kind of computer graphic software. So doing it like this, we've got dogs. There are 7 dogs. So I'm going to have a bar for dog that goes up to 7. So here's my bar for dog. Okay, now I'll do something similar for cat. For cat, there were 4, so my bar is going to go up to 4, and then I will color that in. Now your bars should also be about equal width. So let me show you an example. Let me look at fish. So fish, there were 2. So you wouldn't want to make fish be like really wide, because then someone's going to wonder, why is that one so much wider than the other 2? So the bars should be about the same width, and obviously the height will be different based on how many there were. So 2 fish, so somewhere about there. There's fish. And then hamster, we had 1. So go up to about 1. I'll color it in. So that's an example of a bar graph. Notice that the bars are not touching, they're independent. They don't have to be different colors. I just made them different colors. They could all be the same color. But it's important, again, to remember to label your axes, so pets or whatever your variable is on the bottom, and then frequency is the vertical axis. Yeah, I think that's the important parts of that. A Pareto chart is a bar graph ordered from highest to lowest frequency. So we're asked to create a Pareto chart for the information given in number 1, but we actually just made that. So coincidentally, I put my frequencies in the order of most frequent to least frequent. So if I look, I could, and that's something else that you can do. Sometimes it's hard to tell where your numbers are, especially the further you get from the vertical axis. So you can always label it, putting the number above each bar so that it's very clear how many are in each category. But in this example, I happen to put mine in order: dog, cat, fish, hamster, least, our greatest, most common to least common. So this is also the Pareto chart, so we don't have to do another one. If they're not in order from greatest to smallest, then you could redo it, and that's how you would have a Pareto chart. Okay, so a histogram. A histogram looks like a bar graph, but the horizontal axis is a number line. So this is used for continuous numerical independent variables. In other words, not categories. So like in the last example, we had dog, cat, fish, hamster. In this one, this will be creating one for like number 2, example number 2, where it's test scores. The variable of interest is scores on a test. And so since that's numerical data, we're going to have a histogram instead of a bar graph. In a histogram, the bars are all touching because it's continuous data. So here's the one that we're going to make a histogram for, just as a reminder. So I'm going to make a histogram. I've gone ahead and drawn my axes. So my horizontal axis is going to be the test scores because that's the variable that I'm looking at. Since the classes are intervals of 10, I went ahead and used 10s as my hash mark. And then the frequencies we had were between 1 and 7. So I have the frequencies 1 through 8. And now I'm just going to draw each interval here as a bar. I'm going to go ahead and just use the same color. So for the first interval, it was from 1 to 10. It had a frequency of 2. Okay, then the next class was 11 to 20. It had a frequency of 1. Okay, and that should be right at the 20. Then from 21 to 30, there were 2. From 31 to 40, there were 2. From 41 to 50, there were 1. From 51 to 60, there were 2. From 61 to 70, there was 1. From 71 to 80, there were 6. Looks like probably right about there. From 81 to 90, there were 4. And from 91 to 100, there were 7. All of your bars should be about the same width. There's some variability here because I'm doing it by hand, but try to get it as close to the same width as possible. And again, if you'd like to label above your bars to make sure the frequencies are clear, and in this case, it's not that hard to realize what the frequencies are, except for maybe the higher bars. But just for clarity, you can always do that. So there is the histogram. Notice all the bars are touching, and that's because it's continuous data. Okay, last, a pie chart is a circle with wedges cut out of varying sizes, marked out like slices of pie. The relative sizes of the wedges correspond to the relative frequencies. So your slices of pie correspond to the relative frequencies of the categories. They're usually expressed as a percentage. So as a reminder, here is number 1. It's the pet example. We're going to use these relative frequencies to create a pie chart. So we're going to draw our pie chart. We need a circle. So here's my circle. And now we want to split the circle up, matching the relative frequencies. So the dog is the easiest part. The dog is 50%. So you're just going to cut your circle in half. And again, this is hand drawn, so that is not half. It looks like the left might be a little bigger than the right, but we're going to label it. So this is dog, and we're going to label it as 50%. Now we have cat, fish, and hamster. So cat is 28.6%. So if we were to cut this in half, this right side, that would be 25%. So we want it to be just slightly bigger than that. Maybe like that, and it should be a straight line. So cat is 28.6%. And then the other portion, 14.3%, is fish, and hamster is 7.1%. So if we split that up, one should be about twice as large as the other. So we'll have fish, 14.3%, and hamster is 7.1%. So it's always good to draw or create your graphics using some kind of computer software so that it's more exact. It's going to be very rough if you're doing it by hand because you can't be exact. This just gives you an idea of what it looks like.